All right, so it's one thing to be able to create 3D digital prototypes inside of Inventor. It's an altogether different thing to make these components work. And I'm here with Darren Nickel. Darren, how you doing?
Pretty good. How you doing?
Good. Tell us a little bit about what you do here at R&D.
My main function is I'm the senior controls designer, and we design the panel, PLC layout, power distribution, DC motor drive control. So we have to put that entire package together and make the machine function.
All right, so when you see one of these models from the engineering side of the house, you kind of look at it and go, yeah, but guys, we got to make this thing work. Do those 3D models actually do you any good when when you're going through a review process or planning out a design?
Yes, they do, and here's a good example. What we have is a 3D model of a station, and we'll do a design review over this station. Now, what this allows me to do is visually see how this station should work, and it allows me to start my programming sooner.
Nice.
So that's a key advantage.
So you're able to start your programming even before they start assembling this thing?
Correct.
So how's that impact then your, when you compare that to other places maybe that you've worked where, it's maybe more after the fact? Have you experienced that before?
Correct. In the older days, it used to be we had to wait for all the machine parts to come in. A machinist would assemble the parts, then the control guy would come out and actually look and try to figure out how does this station truly work.
All right, so one of the most important deliverables from your point of view then is certainly going to be the electrical bill of material. Now, how quickly are you able to react to changes from a 3D model then to your schematics, your PLC, your controls drawings?
As soon as they update it, we're on the fly, we do the changes. If we need additional parts, we get those on order and get them rolling in.
So how do you take the ins and outs and the lead-ins and the lead-outs and your home run wires and document those I'm assuming you're using some form of AutoCAD to be able to do that?
Correct. Well, there's two parts to that. For the Inventor side, we actually have wireway on the machine, and the machine enclosure is actually part of the machine frame. So the guys will model that in their drawings and come up with the main wireway drops. At that point, it's custom design. We'll find the best routing for all the cables for the field devices.
How are you able to take the mechanical design information and then turn that into a program? Walk me through that process here a little bit so I understand a little better.
The first thing we actually have to do is get it on the same terminology. They will actually start naming components in this station, and I will take that name and actually put it in our schematics, then also put it in the PLC program. So now we have a common name all the way through from programming to debug. So we stay on the same terminology through the entire process.
So early access to engineering data and bill of material information is critical to your ability to begin programming that logic earlier in the design process.
Oh yes, it's a definite advantage for that.
So tell me how you react to engineering change. I mean, I'm sure that's documented somehow and communicated to you, and then you're able to react, right?
Oh, once again, they'll do a mechanical drawing. They'll actually put the changes and do a revision change on the drawing and bring it to me. At that point, I'll review it, order the additional parts required for that engineering change, and take it one step further and do the changes in the PLC program. So it's a huge time saving, and now we're waiting for the part to be delivered. As soon as we wire it up, install it, we actually start debugging sooner.
Huh. So far we've heard from a customer point of view, they're able to visualize what they're trying to propose when it's in the early concept phase, and even earlier on in the design, Darren's able to take that information and then begin to build out your program earlier than you would have in other circumstances. It's fantastic.
Great.
Hey, thanks a lot, man.
Thank you very much.
All right. Up next, I hop down the road to JL Precision to learn the value of the Inventor model and how that's being used at one of R&D's preferred vendors for precision machining.